In this video, we'll be learning how to multiply numbers written in scientific notation. And this might be my favorite operation. Well, my second favorite operation would be division. But multiplying and dividing is more fun, I think, than adding and subtracting. Remember, when we add and subtract, the decimal points have to line up. But when we multiply or divide, the decimal points do not have to line up. Also, we learned about some different properties that are going to help us with this. Primarily, the commutative property of multiplication. And if you don't remember what that property stated, it means that when we have two values being multiplied together, we can arrange those two values. So I can flip these two numbers around and or these two numbers around. But remember, when I had multiple numbers being multiplied together, that property had a different name. That's the associative property. Of multiplication. So because I have these two properties, I can flip these two, or I can rearrange this entire problem to put my numbers next to each other, so 8.5 times 3.5, and put my powers next to each other, 10 squared times 10 squared. And because of the order of operations, I'm going to multiply these together. I'm going to multiply these together. So 8.5 times 3.5, I'm going to use a calculator for. This is going to be equal to 29.75. And we know it's going to be 10 to some power. And if you remember the product rule of exponents, that means when we multiply any two together, that's the same as adding their powers. 2 plus 2. So this is 10 to the 4th. Still have to move this decimal point because it's not truly in scientific notation. So we add 1 here. This is 2.975 times 10 to the 5th power. This is why I find it so fun to do multiplication and division problems, because I'm able to rearrange them, and I can use some shortcuts from the properties to really take a load off my mind when I'm solving. Let's look at another problem. What happens if our powers are different? Do we need to make the powers the same? No, we do not. We are going to put these next to each other. So I'm just really going to flip these two right in the middle. So this is 7 times 9.5 times 10 to the 0 times 10 to the 4th. 7 times 9.5 is equal to 66.5. And remember, I'm going to add 0 and 4. 0 plus 4 is just 4. Move my decimal point to the left, so I add another power. This is 6.65 times 10 to the 5th. I want you to try one on your own. 9 times 10 to the 3rd times 4 times 10 to the 10th. Pause the video and solve this. Welcome back. Hopefully you rearranged these. Hopefully your first step was to rewrite the problem, putting the 9 and 4 next to each other and our 10 to the third and 10 to the seventh next to each other. 9 times 4 is 36. 10 to the 3 plus 7 power is 10 to the 10th. But we have to move this decimal point one more place. 3.6 times 10 to the 11th. We have one more problem for you to try. Pause the video and attempt this one on your own. Welcome back. We're going to have 1 times 9.5 times 10 to the negative third plus negative 3. 1 times any number is just that number, so this is 9.5 times 10. Remember, a negative plus another negative, they don't cancel each other out. This is like saying 3 plus 3. This is negative 6.